Hi, this video I'm going to talk about the role of lexical analyzer. So, lexical analyzer is the first phase of the compiler. Uh, Whatever input we got in the first phase, that is a source program, that will pass on to the lexical analyzer. So, lexical analyzer will process the source program, that is scans the source program, and it will be divided into tokens. The other name for the lexical analyzer is scanner. So this is a diagrammatic representation of interaction of lexical analyzer with a parser. So here the source program is given as input for the lexical analyzer. So lexical analyzer will process the source program and it produces the tokens. So that will be passed on to the second phase, that is a parser. So whatever identifier that are available in the source program, that will be stored in the symbol table, and parser will get the token as an input, and syntax tree is produced as output to the semantic analysis. So these are the various tasks that is done by the lexical analyzer. What are the tasks is here? The main task is separation of the input source code into tokens. So the main task of the lexical analyzer is to separate the input source code into tokens. Second task is stripping out of the unnecessary white spaces from the source code, then removing the comments from the source text. So whatever comments that are in the source program, that is removed by the lexical analyzer. Then it keeps track of line numbers while scanning the new line characters. So these line numbers are used by the error handler to print the error messages. And last one is a pre-processing of macros. So whatever macros are there, that is pre-processed by the lexical analyzer. So these are the various several reasons for separating the analysis phase of compiling into lexical analysis and parsing. First one is it leads to simpler design of the parser, as unnecessary tokens can be eliminated by the scanner. Second one is the efficiency of the process compilation is improved. So the lexical analysis phase is most time consuming phase in the compilation. So using specialized buffering to improve the speed of the compilation. Then third reason is portability. So what is portability? The portability of the compiler is enhanced as special symbols and characters that are isolated during this phase. So these are the various reasons for separating the analysis phase of compiling into lexical analysis and parsing. I'll summarize. First reason is the simpler design of the parser. Second reason is the efficiency of the process of compilation is improved. And third reason is portability of the compiler is enhanced as the specialized symbols and characters are isolated during this phase. Next, we are going to describe the tokens, patterns, and lexemes. As it is connected with the lexical analysis, there are three important terms with similar meanings. First one is a lexeme, second one is a token, third one is a patterns. Lexeme, token, and patterns. So first one is token. What is token? So token is a pair. Okay, token is a pair that consisting of token name and optional attribute value. So token means it is a pair that consisting of token name and optional attribute value. What is token name? It consisting of keywords, operators, identifiers, constants, literal strings, and punctuation symbols. So this is actually token. I repeat, what is token? So token is a pair that consisting of token name and optional attribute value. Token name, what are the token names? We have a keywords like if, else, then, these are all int, float, these are all keywords. Operators, so different operators like arithmetic operator and relational operator. Arithmetic operator means addition, subtraction, multiplication, division, and modulus, that is plus, minus, star, slash, and percentage. Similarly, relational operator, less than, equal, not equal. So the greater than, these symbols are called as relational operators. Then identifiers. So what is identifiers? Any variable. Okay, suppose for example a, pi, then similar to that, those are called as identifiers. Then constants, literal strings, punctuation symbols. What is punctuation symbol? Means it is a commas and semicolons. These are punctuation symbols. These things are called as tokens. And what is lexeme? Lexeme is a sequence of characters in the source program that matches the pattern for a token and is identified by the lexical analyzer as instance of the token. So what are the different lexeme we have is less than or equal, greater than or equal, double equal, and not equal. Okay, I repeat, what is lexeme? So lexeme means it is a sequence of characters in the source program that matches the pattern for a token that is identified by the lexical analyzer as the instance of the token. Then what is meant by pattern? So pattern means it is a description of the form that the lexeme of a token may take. It gives an informal or formal description of a token. Example is identifier. There are two purposes. It gives a precise description or specification of tokens. It is used to automatically generate a lexical analyzer. These are the examples. Okay, for example, if first example is if is a token. Okay, if is a token. So informal description. What is informal description is it contains a sequence of character I and if. Sample lexeme is if. Sample lexeme is if. Then else. Token name is else. Okay, token name is else. And what are the characters we have is E, L, S, and E. These are the different characters available in token. Sample lexeme is else. Comparison. So comparison means token name. These are the operators used for comparison. Less than, greater than, less than or equal, greater than or equal, equal, and not equal. Other name we can call it as relational operator also. Either we can call it as a comparison operator or relational operator. Sample lexemes are less than or equal and not equal. Then ID. What is ID is letter followed by letter or digits. For example, pi. So pi is one of the identifier. So here letter is P followed by letter or identifier is I, Pi. So number, what is number? Any numerical constant, 3.14, 159, 0.60, then 6.02, E23. These are called as numbers. Then literals. What is literals? Anything surrounded by, anything but surrounded by double quotes. So here, for example, core dumped. So literal means anything but surrounded by double quote symbol. This is actually called as literal. Okay. Now we are going to find out the different one example for identifier. So here the token names and associated attribute values for the Fortran statement E equal M into C squared. So here what is our first identifier is E. So E is a first identifier. So ID pointed to the symbol table entry for capital E. So what is our token name is? Token name is ID, and it contains a pointer to the symbol table entry for E. Operator is assignment operator. Then second one is again M is also an ID, so it is a pointer to the symbol table entry for capital M. And what is the operator we have is the operator is multiplication operator. Okay. Then again ID, it is pointed to symbol table entry for capital C. Pointer to symbol table entry for capital C. And what is our operator is exponential operator. EXP op, it is a exponential operator. Then 2. What is 2 here? 2 denotes for number, comma, integer value 2. So here what is a value? Integer value is 2. Now lexical analysis. So lexical analyzer, what it will do is it reads input characters and produces a sequence of token as output. So here token, it is a group of characters having a collective meaning. For example, here constant PA equal to 3.14159. Here first one is token 1. Token 1 is CONST. Okay, token name is CONST. Then token 2. So PI. So PI means it is an identifier. So token 1 is a keyword actually. CONST. Token 2 is pi. So pi is an identifier. So token name is identifier. So it is pi. Third one is operator. What is operator? Is assignment operator, equal. So there is no attribute value for equal symbol. Then number. What is the token name is? Next one is a real number. And what is the number we have is 3.14159. Then final token is punctuation symbol. That is a semicolon symbol. Now what are the lexical errors we have? First one, let us consider a statement fi a equal to f. Here when we see the statement itself, we know that fi is a misspelled keyword. Okay, so this error is not detected in lexical analysis because fi is taken as an identifier, not a keyword. Okay, fi means it is a sequence of characters, so it is not a keyword, not a keyword. So it may be considered as one of the identifier. So this error is then detected in other phases of the compilation. In the successive phase, it is identified. Okay. In case of lexical analyzer is not able to continue with the process of compilation, it resorts to panic mode of error recovery. So what is panic mode of error recovery? Is deleting the successive characters from the remaining input until a token is detected. What is panic mode recovery? Is deleting successive characters from the remaining input until a token is detected. So it is deleting extraneous characters. So here we are going to discuss about some of the lexical errors. Some errors are out of power of lexical analyzer to recognize. For example, fi a equal to f of x. However, it may be able to recognize errors like d equal to 2r. Okay, such errors are recognized when no pattern for the token matches the character sequence. So what are the different error recovery techniques available? So we have so many error recovery techniques available. First one is a error panic mode recovery. What is panic mode recovery? Is successive characters are ignored until we reach to a well-formed token. That is a panic mode recovery. What is panic mode recovery? Is successive characters are ignored until we reach to a well-formed token. Examples. First one is deleting one character from the remaining input and insert a missing character in the remaining input. Replace a character by another character. Transpose two adjacent characters. Okay, these are the various error recovery techniques. First one is delete one character from the remaining input. Second one, insert a missing character into the remaining input. Then replace a character by another character. Then transpose two adjacent characters. This is actually called as error recovery techniques. So next one is minimum distance error correction. So it's a strategy generally followed by the lexical analyzer to correct errors in the lexemes. It is nothing but the minimum number of the corrections to be made to convert an invalid lexeme into a valid lexeme. But it is not generally used in practice because it is too costly to implement. Okay, next one we are going to discuss about the buffering techniques. What is buffering? So we are going to discuss about the input buffering technique. So what is input buffering is, the purpose of buffering is how to increase the speed of reading the source program character by character. So a specialized buffering techniques have been developed to reduce the amount of overhead required to process a single input character. There are two types of buffering schemes. First one is a one buffer scheme and second one is a two buffer schemes. So this is an example. Here it is a begin pointer. What is PP denotes for is it is a begin pointer, and what is FP denotes for is it is a forward pointer. So this is a one buffer scheme for storing a input string. So what is a input? What is a example we have taken is integer I equal to I plus 1. Second one is a two buffer scheme storing input string. So buffer 1 int I equal to I plus 1 and second buffer j equal to j plus 1. What is EOF denotes for here is EOF denotes for end of the file. So as I told, the purpose of input buffering is speed up the reading of the source program. It looks one or more characters beyond the next lexeme. There are many situations where we need to look at least one additional character again. So there are two pointers as I told. One is a lexeme begin, second pointer is a forward pointer. The purpose of lexeme begin is it marks the beginning of the current lexeme whose extent we are attempting to determine. Second one is pointer forward, so it scans ahead until a pattern match is found. These are the two pointers we are using for input buffering. First one is a lexeme begin, so it marks the beginning of the current lexeme whose extent we are attempting to determine, and a pointer forward, it scans again until a pattern match is found. Second one is a sentinel. What is sentinel is it reload the buffer, and to advance a forward pointer effectively we have to make two tests. One for the end of the buffer and the other to determine what character is read. This can be done in a combined way if we hold a sentinel character at the end. What is sentinel is? Sentinel is a special character that cannot be a part of the source program. For example, EOF. EOF denotes for end of the file. So this is an example. So buffer pairs. So here we are using two pointers, lexeme begin and forward pointer. So each buffer is of same size, capital N, and N is usually the size of a disk block, example 4096 bytes. By using system read command, we can read n characters in a buffer rather than using one system call for character. If fewer than n characters remain in the input file, okay. So two pointers we are using for the buffer pairs. One is a lexeme begin, another one is a forward pointer. Lexeme begin, it marks the beginning of the current lexeme whose extent we are attempting to determine, and the forward pointer scans ahead until a pattern match is found. So advancing forward requires that we first test whether we have reached the end of one of the buffers. If so, we must reload the other buffer from the input and move forward to the beginning of the newly loaded buffer. So here we have two pointers. One is a lexeme begin, another one is a forward pointer. So once the forward pointer reaches the EOF, so EOF denotes for end of the file. Then we have to reload the next buffer, other buffer. So what is sentinel? Sentinel, as I told, it is a special character, that is EOF. If we use a previous scheme as described, we must check each time we advance forward that we have not moved off one of the buffers. If we do so, then we must reload the other buffer. Okay, there are two tests we need to make, one for end of the buffer and one to determine what character is read. So these two tests can be simplified using additional sentinels. We can combine the buffer end test with the test for current character if we extend each buffer to hold a sentinel character at the end. The sentinel is a special character that cannot be part of the source program, and the natural choice is the character EOF. So this is a figure that is denoting the sentinels. So this figure shows the same arrangement as previous, but with the sentinel as added. Note that EOF retains its use as a marker for end of the entire input. Any EOF that appears other than the end of the buffer means that input is at the end. So this is a code. Okay. Here we are using switch case statement. Switch of forward plus plus. Case is EOF. So first case, if the EOF matches, if the forward is at the end of the first buffer. Okay, we are using two pointers. One is a lexim begin and a forward pointer. So if the forward pointer is end of the first buffer, then we need to reload the second buffer. Okay, then forward equal to beginning of the second buffer. Else if forward is at the end of the second buffer, assume that if the forward is at the end of the second buffer, then we need to reload the first buffer, and the forward pointer points to the beginning of the first buffer. Suppose else, if both the cases are not matching, that is EOF within a buffer marks the end of the input, then we need to terminate the lexical analysis. So these are the conclusion for using buffer pairs. So buffer pairs, lexical analyzer needs to look ahead several characters beyond the lexeme for a pattern before a match can be announced. We use a function called ungetC to push look ahead characters back into the input stream, and a large amount of time can be consumed moving characters. Special buffering techniques, it uses a buffer divided into two n character halves, that is n equal to number of characters on one disk block. One system command read n characters, fewer than n character equals EOF.